Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Display connectors are the physical and sometimes digital interfaces that transmit visual information from a computing device, such as a desktop, laptop, or workstation, to an external display. These displays might be computer monitors, televisions, projectors, or specialized equipment like digital signage panels. The choice of connector directly impacts the quality of the image, the supported resolution, the refresh rate, and whether additional signals such as audio are carried alongside the video. In the CompTIA Tech Plus exam, you are expected to not only identify these connectors by name and appearance, but also understand their capabilities, limitations, and ideal use cases. This means being able to look at a device or scenario and determine the most compatible, effective, and reliable connection method. 4 of the most common display connectors you will encounter are VGA, HDMI, DisplayPort, and USB Type-C. VGA, or Video Graphics Array, is one of the oldest and most recognizable display interfaces still in occasional use today. Introduced in the late 1980s, VGA transmits an analog video signal through a 15-pin connector, most often colored blue for quick identification. This connector uses 3 rows of 5 pins each, and the analog nature of the signal means that the quality can degrade over longer cable runs or when interference is present. Although VGA was once the standard for connecting monitors and projectors, it is limited in terms of resolution support, typically maxing out around 1080p, and cannot match the sharpness or color accuracy of modern digital interfaces. However, you may still see VGA on legacy projectors, older monitors, or in corporate and educational environments where older equipment remains in service. The limitations of VGA become clear when compared to newer standards. Because it is analog, the signal is subject to blurring, ghosting, and color distortion, especially on larger high-definition screens. It also does not carry audio, meaning that a separate cable is required if you need sound alongside the video. The connector itself can be prone to bent pins if handled carelessly, and its larger physical size makes it less suited for slim, modern devices. For these reasons, VGA is no longer recommended for new setups unless there is a specific need to support older hardware. On the exam, you should be prepared to identify when VGA is still appropriate, typically only for legacy compatibility, and when a modern digital alternative is preferable. HDMI, or High-Definition Multimedia Interface, is one of the most common digital connectors for both consumer electronics and computing. It transmits uncompressed digital video along with multi-channel digital audio over a single cable, greatly simplifying connection compared to older setups that required separate video and audio lines. HDMI is found on televisions, monitors, laptops, game consoles, streaming devices, and many other systems. It also supports HDCP, or High Bandwidth Digital Content Protection, which allows for the secure transmission of copyrighted content, such as Blu-ray movies or streaming video. This built-in encryption is essential for compatibility with modern entertainment media. The capabilities of HDMI vary depending on the version in use. Early versions like HDMI 1.4 supported resolutions up to 3080 by 2160 at lower refresh rates, while more recent versions, such as HDMI 2.0 and 2.1, have increased bandwidth for supporting 4K at 60 or even 120 Hz, along with features like higher color depths and support for high dynamic range content. One major advantage of HDMI is its ubiquity. Most modern displays and devices support it without the need for adapters. However, HDMI does have some limitations. Cable length can impact signal quality, particularly at higher resolutions, and while it works well for most single-display setups, it does not offer advanced multi-display management features like daisy chaining that are available with DisplayPort. DisplayPort is a modern digital display interface developed to handle very high resolutions, high refresh rates, and professional-level display requirements. It is especially common in computer monitors aimed at gamers, graphic designers, video editors, and engineers who need precise visuals. Unlike HDMI, DisplayPort was designed with computing first in mind, and it supports features like multi-stream transport or MST, which allows multiple monitors to be connected in a daisy-chain configuration from a single DisplayPort output. This makes it easier to manage multi-monitor setups without requiring a separate cable from the graphics card to each display. DisplayPort cables can also carry audio and, in some configurations, USB data, making them versatile for certain docking station setups. Different versions of DisplayPort provide different levels of performance. DisplayPort 1.2 supports 4K resolution at 60 Hz, while DisplayPort 1.4 can handle higher resolutions with HDR support, and DisplayPort 2.0 increases bandwidth even further for ultra-high-definition setups. A smaller variant called Mini DisplayPort was once common on Apple laptops and other compact devices before USB Type-C became more widespread. DisplayPort is also highly adaptable. It can be converted to HDMI, DVI, or even VGA with the proper active or passive adapter, depending on the signal type needed. For exam purposes, remember that DisplayPort is the go-to connector when you need advanced display management, high resolution, and high refresh rates in a computing environment. USB Type-C has emerged as one of the most versatile connectors in modern computing, capable of carrying data, delivering power, and transmitting video over a single, compact, reversible connector. When used for video output, USB Type-C relies on a feature called DisplayPort Alternate Mode, which allows it to transmit a DisplayPort signal through the USB Type-C cable. This makes it possible to connect directly to monitors with USB Type-C ports or with an adapter to HDMI, DisplayPort, or even VGA displays. Many modern laptops, tablets, and smartphones use USB Type-C for both charging and video output, which has led to the rise of multifunction docking stations that expand one USB Type-C port into multiple display, data, and power connections. However, not all USB Type-C ports support video. Output support depends on the device hardware, so always verify the specifications before planning a display connection. When identifying display requirements, it is important to match the capabilities of the source device and the display itself to the connector being used. Resolution, refresh rate, color depth, and whether audio needs to be transmitted are all factors in this decision. For example, HDMI is a strong choice for home entertainment or general-purpose computing. DisplayPort is preferred for professional and high-performance multi-monitor setups, and USB Type-C offers unmatched versatility for portable and minimalist configurations. VGA should be reserved for legacy equipment where no digital option is available. On the exam, you may encounter scenarios that require you to choose the connector that best matches a given set of requirements while balancing compatibility and performance. Finally, display adapters are essential tools for bridging the gap between different connector types. Passive adapters simply change the connector shape and are used when the signal type is already compatible, such as DisplayPort to HDMI. Active adapters, on the other hand, perform signal conversion, allowing you to connect between analog and digital standards. For example, from VGA to HDMI, at the cost of added complexity and sometimes reduced performance. Knowing the difference between these adapter types ensures you can solve compatibility problems in both exam scenarios and real-world technical support situations. When it comes to cable and connector quality, there is a persistent myth that expensive cables always produce a better picture. For digital interfaces like HDMI and DisplayPort, the image quality is binary. It either works at the intended resolution and refresh rate, or it does not. However, cable build quality still matters because poorly shielded or thin cables can cause intermittent signal loss, flickering, or failed handshakes between devices. Gold-plated connectors are marketed for their corrosion resistance, but they do not improve signal fidelity compared to standard connectors. Cable length also plays a role in performance. With HDMI, Anything over about 15 feet can begin to suffer from signal degradation unless you use active cables or repeaters. VGA is even more sensitive to length because it carries an analog signal, which is susceptible to interference and quality loss over distance. The safest approach is to choose cables certified for the version of the interface you are using, especially for high-bandwidth formats such as 4K at 120 Hz or DisplayPort 1.4 with high dynamic range. Hot swapping refers to the ability to connect or disconnect a cable while the system is powered on and running without risking damage to the hardware. Both HDMI and DisplayPort support hot swapping, meaning you can plug in a monitor on the fly and expect the operating system to detect it automatically. This is particularly useful for portable devices like laptops when connecting to a projector or meeting room display. VGA, especially on older hardware, often requires a manual display detection command or even a reboot before the image appears. USB Type-C also supports hot swapping for display output, but in some cases, the system may need specific drivers or firmware to activate DisplayPort alternate mode. In all cases, the graphics processing unit and the operating system manage plug detection and will attempt to automatically configure the correct resolution and refresh rate once a display is connected. One standout feature of DisplayPort is multi-stream transport, often abbreviated as MST. This technology allows a single DisplayPort output to drive multiple monitors using a daisy chain connection. Instead of running a separate cable from the graphics card to each monitor, you can connect one monitor to the computer, then connect the second monitor to the first monitor's DisplayPort output. This reduces cable clutter, simplifies desk setups, and can lower costs for cabling and adapters. MST requires DisplayPort 1.2 or higher, and all connected monitors must support the feature. HDMI and VGA do not natively support daisy chaining, which makes DisplayPort a preferred choice for professionals and gamers using multi-display configurations. Inside many laptops and some tablets, the built-in display panel is connected to the system using a version of DisplayPort called Embedded DisplayPort, or EDP. Unlike the external ports we have been discussing, EDP is not user-accessible, but it is important for repair technicians and system builders to understand its role. EDP allows for higher resolutions, faster refresh rates, and lower power consumption compared to older internal display connections. This is one reason why modern laptops can feature high-resolution, high-refresh displays without sacrificing battery life or performance. Audio support is another point of distinction between display connectors. Both HDMI and DisplayPort can carry digital audio along with the video signal, allowing for simpler connections to devices like televisions, home theater systems, and sound-enabled monitors. VGA and DVI, by contrast, transmit video only, so separate audio cables are needed if sound is required. USB Type-C can carry audio when used in DisplayPort alternate mode, provided the connected device and adapter support it. When a display connection includes audio capability, the operating system often switches the default audio output device to the connected display automatically, which can be confusing for some users. Knowing how to manually change audio output settings is a practical skill for both the exam and real-world troubleshooting. Different connectors lend themselves to specific use cases. A gaming setup requiring ultra-high refresh rates and variable refresh technology might favor DisplayPort 1.4 or HDMI 2.1, both of which can handle 4K at 120 Hz or higher. A portable business laptop might use USB Type-C to connect to an external monitor via a docking station, allowing video, data, and power delivery over a single cable. Conference rooms may still use HDMI for modern projectors or VGA for older models that have not been upgraded. Professional video editors often prefer DisplayPort for its ability to drive multiple color-calibrated monitors from a single output without signal degradation. Troubleshooting display connections requires a systematic approach. If a monitor shows no signal, first ensure the cable is securely seated on both ends and that the display is set to the correct input source. Next, confirm that the cable is compatible with the required resolution and refresh rate. Updating the graphics driver can resolve detection issues, and in multi-display setups, verifying display arrangement in the operating system's display settings can solve problems like missing screens or incorrect resolutions. Swapping cables or testing the display on another device is a reliable way to determine if the issue lies with the cable, the source device, or the monitor itself. Compatibility and adapter limitations often trip up even experienced technicians. Not all ports support every resolution or refresh rate, even if they share the same connector shape. For example, some USB Type-C ports support only data and charging, not video output. Similarly, converting between analog and digital signals, such as from VGA to HDMI, requires an active adapter with a built-in signal processor. Passive adapters only work when the source device already supports the target signal type natively. Adapters can also limit features like high dynamic range, refresh rate, or audio pass-through, so checking the specifications before deployment is critical. For the exam, familiarity with glossary terms like VGA, HDMI, DisplayPort, USB Type-C, multi-stream transport, alternate mode, resolution, and refresh rate will help you quickly answer identification and scenario-based questions. Flashcards or port diagrams can reinforce recognition skills, and practice with real cables and adapters will deepen your understanding of how these connectors behave in different setups. In real-world IT roles, display connector knowledge is put to use almost daily. Help desk staff guide users through connecting laptops to monitors or projectors. Audio-visual technicians configure conference room systems with a mix of HDMI, DisplayPort, and sometimes legacy VGA. Remote workers rely on USB Type-C or docking stations to run multiple monitors from lightweight laptops. Understanding the behavior, capabilities, and limitations of each connector type ensures smoother deployments, more effective troubleshooting, and better overall user satisfaction. In the next episode, we will move into the world of virtualization and cloud computing. We will explore the concepts of hypervisors, guest operating systems, and how different cloud service models, such as software as a service, platform as a service, and infrastructure as a service, integrate with local and virtual resources. This will set the stage for understanding how physical infrastructure and virtual environments combine to create flexible, scalable, and modern IT systems. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.